Hello guys, am I audible? Am I audible? Hello my ninja warriors, welcome to yet another power packed session for your upcoming KCET examination, and today we are going to start continuity chapter, right? So like before I start any chapter, I know that one question is there in your mind. What is that question, ma'am? What is the weightage of this chapter in my KCET examination? So let me just tell you that I have made a complete video of KCET weightage of mathematics subject. So if I talk about weightage of continuity, so let me just give you some details about it. Continuity and differentiability, I am assuming this as a separate, like combined topic, right? Continuity plus differentiability, and you know what? Continuity plus differentiability, the total weightage of this chapter is 5 questions, right? So you can short get 5 questions from this chapter in your upcoming KCET 2025. Alright, so that means this chapter is very important, both continuity and differentiability, okay? So this is all about the weightage of this chapter, and now we will talk about, for all of those who are coming on this channel for the very first time and who do not know our team, who do not know me. So this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience in both online and offline, and I have taught various students who are currently studying in various IITs, NITs and other reputed colleges as well. All right, yes. So I guess I am not visible, right? I am not visible. Am I not visible? Am I not visible? Hi Malappa. Hi Babu. Hi Shri Vishu. Hi Abhishek. Hi Kush Mohit. Now I guess I am visible. I am visible now, right? I am visible now. Okay, perfect. Perfect. I can see myself. And give me a big thumbs up if I'm audible to you as well. Okay. So, yes. So now let's come back to the topic, the chapter. Let's dive in a little more. Let's know more about continuity and differentiability. Now, understand one thing, that we have actually three close knit topics over here. First one is limits, okay. Second one will be continuity, okay. And the third one will be differentiability. And you know what? It is very extremely important that you study all these chapter in this order only, right? You can't be doing that, okay, first I am doing differentiability, then continuity and then limits. No. First comes limits, then continuity, then differentiability. And you know what? Basically, these three chapters are just like your three consecutive grades. So limits can be your ninth grade, and continuity can be your 10th grade, and eventually differentiability would be your 11th grade. So you know that before not complete, if you do not complete ninth grade, then you won't be get promoted, you won't get promotion in your 10th. If you don't complete 10th, then you won't get promotion in your 11th. So now you know the importance of the order of these three chapters: limits first, continuity and differentiability, okay. So although I'll be focusing on continuity today, but I would like to give you a quick recap, a quick revision for the chapter's limits. Okay, understood? So first 5 minutes I'll be talking about limits, and then once you understand limits nicely, we'll talk about continuity, and we'll do continuity, complete continuity in this lecture. Okay, so the agenda is clear. I hope everything is clear in your brain. I hope there are no distractions. I hope that you guys are sitting there with your pen and paper. You'll make your notes without any distraction, and you have to keep your water bottle aside because I don't want you to go anywhere in this 1 hour. All I demand is complete 1 hour attention from you guys. Okay, then only I can say that yes, I will make sure that you master continuity and you are going to solve each and every question that you're going to come across in your KCET mock exam or KCET actual paper. Okay, all right. Yes, clear. I guess we are clear about it. Now let's talk about limits, okay? Before actually I start limits, I have one story to tell you guys, okay? One small story I would like to introduce. Now, how many of you are watch criminal series, crime drama? Can you just name any of your favorite crime drama series? Can you just name your drama series? Okay, crime drama series, or you can call it as movie as well. Can you just comment below any of your favorite crime drama series? Okay, yes, in the chat box. I am looking forward to it. So mine is Crime Patrol. Okay. So Crime Patrol, I like it a lot. Although I'm not in favor that you guys should watch such series because it has negative impact on our brains. But like I used to watch earlier, now I have completely stopped watching big movies, crime dramas and everything. But I have a little context from the chapter limits over here. Suppose basically we all know that what happens in these crime dramas, that sometimes like a crime has happened. For example, a person goes missing or something like that. Okay, so what happens is Indian police come into the picture. Okay, so whenever somebody is missing or something is wrong, Indian police always come late. है ना? This is such a stereotype in India that Indian police never come on time. When the crime is happening, they are not here. But when the crime is dusted, then they will come, then they will do some inspection and they will execute their proceedings, right? I guess, yes, I'm seeing to Turkish drama, CID. Oh, nice, CID. Yes. So, yes. So, I have a story to tell. Suppose there was a guy named Chintu. Chintu was living in this building. Okay, this building name, give me a building name. Okay, building name could be Rose Rhythm. Okay, Rose Rhythm building. Chintu is staying over here, and on his like society road there is some tea stall, correct? And after that, here there is some pakoda, like the fryams we call as fryams stall. Okay, so what happens is, uh, a friend of Chintu calls to the police station and tell them that his number is not reachable and he is missing. So basically 26th October, like his friend Mintu, 26th of October, his friend Mintu starts calling Chintu and he realized that he is not able to call him. And then he called everybody. They all friends, all family member were like, no, we have not seen him after 26th October. So Mintu calls police station, informed that my friend is missing. Now from police station, police comes for inspection. Now a policeman is right here, you can see. Okay, a policeman is right here. And yes, then what will happen? They will start interrogating, they will check the phone records, they will do everything. Okay, they'll do everything, they'll check phone records. They'll realize that 26th October 5 p.m, basically not 5 p.m, 4:59, Chintu's phone was off. Okay, now what they did is they realized that, okay, location of the phone was around his society Rose Rhythm only. So they came, they start asking, they went, they were starting inspecting, they start roaming around. Then they went to tea stall. The tea stall guy told that approximately 4:45 p.m, Chintu was here, he was drinking tea at the tea stall. Then they were like, okay, then they go ahead. Then there is a Fryam stall. Police ask Fryam owner that, did you see Chintu? So he told yes. 4:50 p.m. they saw Chintu. He was talking on phone, having some Fryams, and then he left. Okay. So basically, and then call records shows that 4:59 his phone was active. That means what they were doing is, the missing Basically, the Chintu goes missing at 5 p.m. Do you agree? Chintu goes missing at 5 p.m. Right? And what police did understand, there is some issue at 5 p.m. Right? At 5 p.m. 26 October, what happened? There was some issue. Issue was there. Okay. So what they did is they started reaching out to people. They wanted to know that what happened before, just before 5 p.m. Before 5 p.m. what happened? What happened before 5 p.m. to Chintu? Because if they are able to decode that what exactly happened before 5 p.m., they might be able to know that what would happen, what would have happened at 5 p.m. What does that mean? What does that indicate? What do we learn from it? We learn that if something is wrong at some point of time, then what we do is we go just before or just after to understand the whole situation. Are you guys getting my point? Yes? Are you guys getting my point? So here comes the concept of limits. Okay? So suppose here is this number line. Let me draw a number line. Here there is x equals to 2. Okay? So suppose you are having some x equals to 2 and you are having a function f of x, and at x equals to 2 you are find out what is happening at x equals to 2. You're not able to figure out that what is happening at x equals to 2, then naturally but obvious that your next thing in your mind would be, okay, if I am not aware about what is happening at x equals to 2, why don't I do one thing? I will check at x equals to just before 2. So that means x equals to 1.99999. Let me check at just right before x equals to 2. Or let me check just right after x equals to 2. So x will be equals to 2.00001. So basically what I'm trying to tell you, there are 3 ways to approach a function at a given point. Okay, there are 3 ways to approach a function at any given point. Obviously at x equals to 2, that means you are talking about exactly 2, right? So that means you call it as f of 2, right? We denote it as f of 2, correct? At x equals to 2, right? First way. Second way is that I told you that this is x equals to 2. Second way is approaching this function from the left hand side, okay? So that means at x equals to 2 minus. What is 2 minus? So this is a new term which you are maybe seeing right now. X equals to 2 minus means x equals to 1.99999. Okay? Or we can also write it in another manner, that x equals to 2 minus h, where it is obvious that h is a small quantity. Small quantity. Okay? So the second way is approaching the function from the left hand side, that is x equals to 1.99. We will write it as f of 2 minus, or we will write it as f of 2 minus h, or we will write as limit of the function fx where x is tending towards 2 minus. Are you getting my point? This is very important. Okay, this is something you should understand. So basically what I am trying to teach you is the representation. The representation I am trying to teach you. Overall all these things is what? Indicating the value of function. So these things, this is nothing but f of 1.999. This is just the way of writing. Okay. And the third thing is, the third way of approaching is at x equals to 2 plus. Or you can say x will be equals to 2.0000001, or you can say x equals to 2 plus h. Again, where h is again small quantity, small positive quantity, right? So you are adding some small positive quantity to your 2, that will 2.001, right? Quantity. Is that clear till now? Is that clear? Yes. Are you guys like understanding what I'm trying to say? So there are 3 ways to approach a function. I told you, one is at exact 2, one is just after 2. Okay. Now let me just write these 3 ways. So these 3 ways are like this. Okay. So now limit, the definition of limit says definition of limits. Let me just tell you the definition of limits. Definition of limits. Okay. Definition of limits. That suppose you are talking about a function f of x. Okay. And you are talking about x equals to a. Understanding? X equals to a could be 2, like in the previous case we have taken specific x equals to 2. So here a could be either 1 or 0 or 2 or 3 or any real number basically. Okay, so there you have a function now and you are looking at a specific point, right? Now I already told you that there are 3 ways to approach. Now definition of limit says that you have to understand the left hand limit of that function. Limit of function. So left hand limit of function will be limit of f of x where x is tending to a minus. This is how you write things. This is how you mathematically express things, right? I'm not here. I will not always write, okay, just tell me f of 1.999999. No. I will say limit of the x equals to 2 and here I am talking about the left hand limit. That means you have to go a little on the left side. Okay, what about the right hand limit now? Right hand limit of function will be limit of x tend to a plus f of x, right? This is your right hand limit and this is also can be written down as f of x, f of a minus h. That means f of a, you are not looking for f of a, slightly less than a. So this will be a minus h, a plus h. This is f of a plus h. Okay. All right. So basically I will be talking about, when I talk about limits, I'll be talking about 2 things. What are those 2 things? Left hand limit and right hand limit. Okay. Now let me just come back to the definition of limits now. Of a function f of x exists at x equals to a if LHL of that function is equals to RHL of that function is equals to L, which is a finite value. If LHL and RHL both are equal, ma'am, what is LHL? When you approach the function from left hand side, that is your LHL, x minus. This is what is RHL? Limit of fx x tend to a plus. If these 2 values are equal and on top of that finite, then we say that at x equals to a, limit exists. Okay. Are you getting my point? Yes. Is it clear? Both the things are clear to you guys? Yes, yes, yes. Let me know, let me know. Okay. Ma'am, we can also say function is continuous. Yeah, continuity is a later thing. Okay, let me just focus on limits right now. Now, suppose I have given you a function f of x equals to x plus 2. Correct? Now, I just want you to tell me that limit of f of x where x is tending towards 1 plus will be equals to what? That is, I am talking about right hand limit. Let me just, you just tell me limit of this function f of x, x tending to 1 plus, sorry 1 minus, this is your left hand limit, and just tell me, my question is that what do you think, limit will exist or not? Tell me in the chat box. Tell me in the chat box. Tell me. Okay. Okay, all right. So let's just understand that what I'm trying to say. So I want you all to calculate f of 1 plus. That will be your right hand limit. Or f of 1 plus h. So basically, you have to replace your x by 1 plus h to get the right hand limit. Okay. So this is going to become x will be replaced by 1 plus h. So 1 plus h plus 2 will be equals to 3 plus h, and this h is a very small quantity, like very positive small quantity that can be neglected in the final answer. So this is 3, ma'am. Right hand limit is coming out as 3. Okay. Now f of 1 minus, or you can say f of 1 minus h. So this is going to become what? 1 minus h. This time you have to replace x by 1 minus h. Again, h is the smallest positive quantity. Plus 2. So this is what? 3 minus h. So this is 3. So in this case, limit exists. So LHL and RHL are equal. And they are finite as well. Right? That means limit exists. Exists. Okay. Alright, limit exists. Cool. Perfect. Now, shall I give you one more question? Let me give you one more question. F of x equals to x square minus 4 upon x minus 2. And I'm just asking you now, I will not prompt you. Now, you have to understand. You have to understand that what I'm trying to ask you. Just tell me. Limit of f of x, you have to tell me, when x is tending to 0 is what? Options are exists, option B does not exist, D and E. Okay, and if exist, then what is the value of that limit? If does not exist, then I am not here, like I don't want, I just don't care. Then if does not exist, that means the value does not exist. Okay, all right, let's see. Okay, so now what we will do is we will solve it. Okay, so clearly the moment I will put 2 right here, if I put 2 right here, x equals to 2. Okay, f of 2. So f of 2, if I put, it is 0 by 0. So f of 2 is not existing. F of 2 is something which is like indeterminate. Okay, not defined, we can say. Okay, f of 2 is absurd. Okay, but we are not here to look for f of 2. Did I ask you f of 2? Understand, limits is not about what is happening at x equals to 2. Limits is all about what is happening just before 2 and just after 2. And these two equal values, if at all they are equal, then limit will exist. And if they are finite also, limit will exist. Otherwise, it won't exist. So in this case, f of 2 is not there. F of 2 is something random. It is something wrong with f of 2, right? But still, we still have that chance of limit to be existing. That we have to understand. So f of x, now if I split this, it will become x plus 2, x minus 2 upon x minus 2, correct? Now understand that I can actually cancel these two terms and I can just write that x cannot be 2. Okay. So over here f of x will be equals to x plus 2, but only when your x is not 2. Because if your x is 2, then what will happen? Tell me. If your x is 2, then it is actually in the original question, it is 0 by 0. In this updated version of fx, if you put 2, you will get 4. Okay, so here you can't put 2 over here, because the original question is not allowing 2. You're modifying the question and you're putting 2, not allowed. So f of 2 is definitely not defined in this case. Now this is your f of x when x is not 2. Okay. Now let us talk about left hand limit. Left hand limit means that you are looking for limit of function when x is 2 minus, that means f of 1.99999, or you can say f of 2 minus, or you can say f of 2 minus h. So f of 1.9999 you can put, f of 2 minus you can put, f of 2 minus h you can put in this function, right? Only thing which you can't put is 2. Okay ma'am, cool. So f of 2 minus h will be what? 2 minus h plus 2, that is 4 minus h, where h will become 0, right? So f of 2 minus h equals to 4 over here. Okay ma'am, that means left hand limit is there. Left hand limit is not like something wrong. Okay, what about right hand limit? Now tell me, what about right hand limit? So right hand limit again, this is limit f of x, x tend to 2 plus, this will be f of 2.0001, correct? And this will be what? F of 2 plus h, and that will be, if you put f of 2 plus, so basically you have to replace x by 2 plus h, correct? So if you do that, x will be 2 plus h plus 2, so this is 4 plus h. Again, h is very very small quantity, you can plug in 0 in place of h, right? So this is again 4. So your right hand limit is also coming out as 4. The moment you see that your left hand limit is matching with your right hand limit, that means limit exists and is equal to 4, my dear students. So can you see, this is the best example. Here you can clearly see that even though something is wrong at x equals to 2, but at x just less than 2 and greater than 2, everything is fine, they are equal as well. So we can say that yes, limit exists, although f of 2, the situation is, you can see 0 by 0, very wrong situation. Yes, clear? Perfect. All right, now let me just give you one more example graphically, graphical example, and you just let me know what do you think about the graphs. Okay, because I want you to understand the graph also, right? Understanding of the graph should also be very very important. So this is x equal to a. Okay, and now this is your graph. Okay, I have a few questions for you, and this is your L2, this is your L1. Just tell me, first thing, what is f of a? Second thing, limit of function at x tend to a minus. Third thing, limit of function at x equals to, x tend to a plus. Okay, and fourth thing, finally, limit value exist or not. Clear? Yes, my dear students. Okay. Let me know in the chat box. Also, if you have not liked the session, I just want to know that why you guys have not liked my session, huh? Do like it right away. Okay. Okay. So f of a. So value of this function at x equals to a. Do you understand how to read that graph? So this is an open circle. This is a closed circle, solid circle. So at x equals to a, you are going to get this value. X equals to a, you are going to get L2. So L2 is the value of f of a. Yes? Ma'am, should we copy everything what you write? Abhishek, it depends if you have that speed that you can match up. So you can do that. But anyway, I'll be providing PDF. So what you can do is later on you can also watch the recording as well, and you can just note it down later on. If you just want to focus on understanding and you just do the calculation, right? And just keep a rough pen and paper, do the calculation, let me know, and then later on you can make your own notes. You will have the recording as well. Okay, so f of a clearly is L2. Now what is the left hand limit of that function? That means f of a minus, this is left hand limit, that means f of a minus the value of function at x equals to slightly less than a. Can you see I'm looking for here less, left hand limit, so this is close to L1, close to L1. Can you see? So this will be L1. Now we are looking for right hand limit, that means f of a plus. So we'll go just right towards the a and I will just see that my value is becoming L2. Okay, what does that mean? L1 and L2 right hand limit is not equals to left hand limit. Okay, so that means limit does not exist. Limit does not exist, my dear students. Okay, all right, clear, perfect, yes, all right. Okay, so I guess the concept clear to you that no, what is happening at x equals to a, we are like blind towards what is happening at x equals to a. We are ignorant about what is happening at x equals to a in case of limits. But now let me just talk about continuity a bit. Continuity. Continuity. Okay, here comes the concept of continuity. Okay, all right. So continuity says that obviously, so definitely should exist. Okay, so basically limits is your class 9th. So if you are studying continuity, if you are checking continuity, the first thing is continuity. For continuity, limit should exist, and now that limit should be equal, that limit should be equals to function of the value. In this continuity, we will not be ignorant about what is happening at x equals to a. Let me tell you. Okay, so see, basically continuity says, so continuity, if you have a function f of x and at x equals to a, function, let me write the definition. A function is said to be continuous at x equals to a if left hand limit of the function is equals to right hand limit of the function is equals to f of a, and all should be finite. So this is the clear-cut condition of continuity. So can you see, one more step is added. Left hand limit should be equals to right hand limit. But now this time it should be equals to f of a. Right? Then we can say that if all three are equal, then the function is continuous. Okay? Alright, clear? We can also write it as f of a minus equals to f of a plus equals to f of a. This is also another way of writing. Or you can write it as f of a minus h, f of a plus h equals to f of a. Just let me know if it is clear to you guys or not. Clear or not? Yes, perfect. Definition of continuity is clear. Now, Let me give you another definition, the graphical definition. Okay, one more definition. Continuity of a function. Okay, continuity of a function, correct? A continuous function, a continuous function is a function, okay, that does not have any abrupt change. What do you mean? Abrupt change in value. Okay, that means no break in their graph. Okay, so let me just draw one of the graph. So see, this is your continuous function. Can you see? There are no breaks in graph. If I have to draw the graph, this is x-axis, this is y-axis, and can you see the graph? That graph is actually smooth graph. I don't have to lift my draw this graph. But the second graph on the other hand, can you see that this graph is having a break point? This is the break point. Okay, so to plot this graph, you have to pick the pen and draw it again. So there is a break. So this left function is a continuous function, discontinuous function. Clear? Yes. Okay. So now I'll be asking you some questions. Are you ready for it? Are you ready for that graphical test of yours? Are you ready to test yourself? So test yourself. Okay. Now you are going to tell me which graph is continuous and which is not. Let me draw a few graphs. Okay. So yes, this is your graph, and yes, this is how it is. This is L1, this is L2, okay, and this is x equals to a. So you have to tell me about the limit at x equals to a, and second thing, continuity at x equals to a. Just tell me in the comment section, okay. Alright, so and what about this? So this is the graph, this is x equals to a, this is your L1 and this is your L2. In the second graph you have to tell me again limit at x equals to a, and what about continuity at x equals to a? Come on, in the chat box, let us see how many of you are able to clear your doubts. I am waiting for you guys right here. Okay. All right. Now, let us look at the first graph. Okay. So clearly the left hand limit of this graph will become what? L2. So LHL is L2. What about RHL? RHL, that means you are approaching the graph from the right hand side. Can you see this is how you approach? This is left hand side, this is right hand side. Can you see that here this is L2, L2, L2. So, sorry, left hand limit is L1, L1. Sorry guys, right hand limit is L2. These two are not equal. That means limit does not exist. And if limit does not exist, hello, continuity will not exist. So continuity, the function is discontinuous. This is a discontinuous function. Okay. Are you getting the logic here? Okay. Alright. Now, in the second graph, again, limit at x equals to a. So let me just write down left hand limit of this function. So we are approaching the limit, the graph from the left hand side. So approaching the graph from the left hand side will give you L1. Left hand limit is L1. What about right hand limit? So ma'am, right hand limit will also be actually L1 in this case. Okay. So limit is existing and the value is L1. What about continuity? Okay. So left hand limit is L1, right hand limit is L2, limit value is L1. What about f of a? So can you see f of a, there is a hollow circle and there is a solid circle. So at x equals to a you will have L2 as the value. So in this case, even though limit exists, limit is existing, left hand limit, right hand limit are equal, but unfortunately it is not equal to the value of that function. So the function is discontinuous at x equals to a. Are you getting my point? Are you guys getting? Yes, yes, yes. Definitely. Kushmohit, Malappa, Abhishek. Yes. So I guess now that your concepts are clear, what do you think? Are you getting that confidence that yes, I know the definition of limit, I know the definition of continuity, and now I can just start doing some problems? What do you think? Are we ready to start some problems? Yes? Okay. So let me give you a question. So question is, you have to discuss the continuity, of function defined by f of x equals to x plus 2 and minus x plus 2 if x is less than 0, if x is greater than 0. Okay, so do you want to try it? Okay, so there are two ways to go about it. There are two methods. Method number one will be graphical method. Okay, graphical method. So graphical method is obviously you have to plot the graph. Once you have plotted the graph, then to its graph is smooth or not, right? Smooth graph can be visually, like you can see it, tell it it's smooth, it's not smooth. Okay, all right. So graphical method. Now let me just understand what they are trying to say. So fx is equals to x plus 2 if x is less than 0, right? X is less than 0. So this is minus x. When x is negative. So when x is negative, your graph will be x plus 2, right? So just put any negative value. Just put a negative value, right? So put minus 1. So the moment you put minus 1, you will get 1. The moment you put minus 2, so put minus 2 over here, you will get 0. Okay, so put minus 1, you will get 1. So these are the 2 points. I am plotting the graph. The moment you will put 0, although 0, putting 0 is not at all allowed. Can you see? Putting 0 is not allowed. Okay, so putting 0 is not allowed. So 0, but even though if you put 0 here, so you will get 2. So this is your graph. Okay, because x equals to 0. Can you see here also there is no equality, here also there is no equality. So that's why your graph will look like this on the left hand side, x less than 0. And for x greater than 0, what do you have? You have minus x plus 2. Again, you have to put x equals to 1. So minus 1 plus 2 is what? 1. So this is how it is. You put x equals to 2, you will get 0. Okay, put x equals to 2, you will get 0. So simply just the how to plot the straight line. So this is how your graph will look like. Now, just tell me one thing, that first of all, left hand limit will be equal to what? F of 0 minus. So basically you can see that the graph is actually smooth on the left hand side of the x-axis. This is smooth, and on the right hand side is a smooth. The problem here is this. At x equals to 0. So problematic area is x equals to 0. Are you understanding? So we will check the limit at x equals to 0. Okay. Right. So what we are going to do is left hand limit. So left hand limit is this. This is your 2. So left hand's limit. If I approach the function from left hand side, it is approximately 2. So this is 2. Right hand limit f of 0 plus, if I approach the function from right hand side, this is a 2. Okay. And yes, left hand limit, right hand limit, both are equal. So limit to exist. But I just want to know limit exists. I just want to know what is f of 0. F of 0 is not defined. They have not given what will happen at x equals to 0. So limit exists, but the value of the function is something which we don't know. So this function is not continuous. For this function, now we can, they have like given the question where we have to discuss the continuity. Okay. So basically what we can say that if f of 0 is becoming 2, if the question creator will agree on it ki f of 0 is 2, then function will be continuous at x equals to 0. Correct? Yes? Clear? Okay. All right. Now, a little bit information I want to give you on continuity. Generally, polynomial function, logarithmic function, trigonometric function, exponential function are continuous in their domain. What do you mean, ma'am? What do you mean by that? So let me just go back and make you understand. This is x plus 2. This is a polynomial, right? Linear function. So x plus 2 individually is continuous. Minus x plus 2 is also continuous. So remember I was saying on the left hand side the graph is smooth. On the right hand side the graph is smooth. I don't have to worry about when x is positive. I don't have to worry about when x is negative. All I have to worry about this break point at x equals to 0. The function is breaking. Right? This is a piecewise function. So I have to worry about where the function is breaking. Okay. So whenever you get polynomial, logarithmic, trigonometric, exponential functions, these type of functions will be continuous in their domain. Okay. Now let me just give you one question over here. Okay. One question. Okay. Yes. So just there is this question, very easy question I will say. F of x equals to 2x plus 3 if x is less than or equal to 2, 2x minus 3 if x is greater than 2. Okay. Now you just have to tell me whether the function is continuous at x equals to 2. Okay. All right. Clear? Yes. All right. So, ma'am, see, although they have given at x equals to 2, but in case they would have just generally given you that just tell me the continuity of this function overall. So, understand, this function is continuous individually. 2x minus 3 is also continuous. So, for x greater than 2, I don't have to worry about it. Because x greater than 2, you have 2x minus 3. 2x minus 3 will be smooth graph. For x less than or equals to 2, 2x plus 3 again polynomial smooth graph. The problem over here is the break point. Break point is happening at x equals to 2. So, we'll check at x equals to 2. How to check now? Method number 2. Right? This is a algebraic method. How to do it? Algebraic method. You don't have to plot the graph. So, what you have to do is for a function to be continuous, at x equals to 2, correct? F of 2 minus should be equals to f of 2 plus should be equals to f of 2, correct? Now what is f of 2? Tell me f of 2. Where is f of 2? Hold on. Equality. X equals to 2. X equals to 2 can you see here? That means you can put x equals to 2 here. So 2 plus 3. So this is 7. Okay. Now f of 2 plus, that means x is greater than 2. Which branch you will hit? Tell me. You will hit this branch, x greater than 2. X greater than 2 here. So f of 2 plus will be 2. 2 plus minus 3. Correct? So this is 2 2s are 4 plus minus 3. So this is 4 plus minus 3 is approximately 1 plus 1. We will be writing 1. Okay. Can you clearly see these two are not at all equal? Right? The right hand limit is not equal to value of the function. I don't have to like check it out. I don't want to waste my time. Come on, this is a KCET competitive examination. I have to save my time. Do you want me to check f of 2 minus? I won't do that. So function is, because this is not happening, so the function is discontinuous. Clear? Yes. Perfect. Shall I give you another question? Shall I give you another question? Okay. Let us see. Now let us see how many of you will be able to decode this question nicely. Okay. So the question says that find the relationship between, okay, A and B so that the function f defined by f of x equals to ax plus 1 bx plus 3 if x is less than or equals to 3, if x is greater than 3, is continuous at x equals to 3. So this is the question. Differentiability, next topic guys, next topic. Okay. All right. Yes. So find the relationship between A and B so that function is continuous at x equals to 3. What does that mean? Let us apply the condition of continuity. F of 3 plus is equals to f of 3 minus is equals to f of 3. Right? Yes. Okay. So f of 3 minus. F of 3 minus, ma'am, that means, okay, actually I always think that don't do f of 3 minus, don't do f of 3 plus. I always focus on f of 3 first. While continuity, f of 3 is love, okay. F of 3, so equality is right here. Can you see x less than or equal to 3? Obviously f of 3 will become what? A into 3 plus 1. So basically 3a plus 1. Correct? Now f of 3 plus, that means x is greater than 3. So you have to look for this branch now. So you have to put 3 plus over here. So this is b into 3 plus 3. Correct? So this is 3b plus 3 approximately. Right? So this is the relation now. 3b minus 3a is equals to minus 2, or you can say that a minus b is equals to 2 by 3. This is your relation between a and b. What do you think? What do you think? Sorry Abhishek, you have done a small mistake. Smaller mistake. Okay. One more question. Are we ready for it? Yes. No, Kush Mohit, no. It is not discontinuous. In the question, they are saying that the function is continuous at x equals to 3. How can you say that? They are not asking you about whether this function is continuous or not. They are telling you, dude, that the function is continuous. Okay? Alright, Kush Mohit. So now you have to apply that condition of continuity to get the relation between A and B. This is a different type of question, very important type. These type you will see in your upcoming PUC examination as well as your KCET examination. Okay. Yes, Kush Mohit, is it clear? Okay, all right. Now, let me give you one more question. What do you think? One more question, are we ready? Question, okay. Find the value of lambda for which function f of x equals to lambda x square minus 2x, and we have 4x plus 1. This is x less than or equals to 0, x is greater than 0. Okay. Now this function, they are telling, again Kush Mohit, they are telling you this function is continuous at x equals to 0. So now the function is continuous at x equals to 0, my dear students. Okay, this is your question. What about the solution? Let me know, let me know, let me know. Okay. So ma'am, if the function is continuous at x 0, then f of 0 minus equals to f of 0 plus equals to f of 0. Now I always target f of 0. Can anybody tell me what is the value at x equals to 0? So ma'am, the value at x equals to 0 will become lambda into 0 square minus 2 into 0. Okay. Alright. So this is 0. Cool. Now, if I talk about f of 0 plus, so 0 plus will come from here, x greater than 0. So this is 4 times 0 plus 1. So this is 0 plus 1, so basically 1. Okay. Okay, so 1 equals to 0. Oh my god. Oh my god, what is happening? What has just happened? Okay. Like the continuity of the function at x equals to 0, can you see, is not depending upon lambda. Can you see it? F of 0 is coming out as 0 and f of 0 plus is coming out as 1. They are not equal. F of 0 plus is not equal to f of 0. That means no value of lambda can save this. This function is basically no value of lambda. No value of lambda will be there for which function is continuous at x equals to 0. Okay, so this is a different kind of question. This is a googly question. Okay, clear? Shall we move on to the next problem, guys? One more question on our plate? Yes? Let's do one more question. What do you think? Are we ready for one more question? Okay, two more questions actually. I will give you two more questions. Okay, so the question is, now these are the important types what we are doing. Find the values of a and b such that the function fx defined by, so this is 5, this is ax plus b, this is 21. If x is less than or equals to 2, x is greater than 2, and less than 10, x is greater than or equals to 10, is a continuous function. Now the things are a little bit trickier. Understand the question nicely, okay Kush Mohit? Abhishek, are you here? So you have to figure out the values of a and b. For this function is continuous. Just that. They have not telling us like continuous at what? Continuous at x equals to this, continuous at x equals to this. So now we have to analyze that what are the doubtful points? What are those points? Obviously I cannot, like, there is the complete number line. On this number line there are infinite numbers. Can I just check the continuity at each and every point? Can I check continuity at x equals to 1, 1.1, 1.2? No. There are so many numbers. I have to pick the doubtful points. What are the doubtful points? So we are going to check the continuity of the function where the function is breaking right here. So the function is breaking, can you see, at x equals to 2 and 10, right? So two things you have to check the continuity twice. First thing, as at x equals to 2, f of 2 minus should be equals to f of 2 plus should be equals to f of 2. Now you know, I always attack f of 2. What will be the value at x equals to 2? X equals to 2, equality I can see right here. F of 2 is 5, ma'am. Yes? F of 2 plus, that means x greater than 2, my dear students. X greater than 2. Can you see x greater than 2 right here? So this is going f of 2 plus. So you have to put the value of 2 plus over here. So this is going to be a into 2 plus b. That's it. Okay. So basically 2a plus b equals to 5. This is your first equation, my dear students. Now at x equals to 10. So again, for a function to be continuous, the question creator has asked us that this function is continuous everywhere. We are just picking our points. At x equals to 10 we are doing. So f of 10 minus is equals to f of 10 plus is equals to f of 10, correct? What is f of 10? Tell me. What is f of 10? So ma'am, f of 10 is clearly very simple. Equality is right here. So it is 21. What is f of 10 plus? That means greater than 10. That is also 21. X greater than 10, you will get 21. F of 10 minus. Can you see 10 minus right here? 10 minus. So you have to plug in 10 over here. So a into 10 minus plus b. So this is 10a plus b equals to 21. This is your second equation, my dear students. Oh my goodness. Right? So now you have got two equations, two unknown. You just have to solve them. Right? 2a plus b is equals to 5. And let me go back. 10a plus b is equals to 21. Subtract. 8a is equals to 21 minus 5 is going to become 16. A equals to 2. A equals to 2. The moment you put A equals to 2 over here, so 4 plus B is equals to 5. B equals to 1. Yes? So A equals to 2 comma B equals to 1 is your final answer, my dear students. Yes? Getting it? Are you being confident now? Are you like understanding what I'm trying to say? Okay, all right. Now we have the last question of the day, and this was asked in KCET examination. KCET question, and one homework question also I'll be giving it to you. Okay. KCET PYQ. Are we ready for the KCET PYQ? Yes. Okay. Let us understand this question now. So yes, if fx is this, okay, fx they are giving. Now we have to figure out the function at x equals to 2 and right hand limit of the function as x equals to 2. So roots of the quadratic equations are left hand limit and right hand limit. Okay, left hand limit is f of 2 minus and right hand limit is f of 2 plus. Now f of 2 minus is your first root, that you can call it as alpha. F of 2 minus, tell me, that means you're looking for x less than 2. Yes, x less than 2, x less than 2. Can you see here? X is less than 2. Correct? Okay. Alright. X less than 2. So you have to plug in 2 over here. So 2 minus whole square minus 1. So this is going to be 2 ka square is 4. 4 minus 1 is 3. Alpha, one root of the quadratic equation is 3. Beta will be the right hand limit, you can see. So this is x greater than 2, my dear students. Greater than 2. So x is greater than 2. Can you see the equality over here? So this is going to be 2. 2 plus 3. So this is 2 2s are 4. 4 plus 3 7. So see, As per this question, the limit does not exist. They are not asking you that. They are only talking about calculate left hand limit, which is 3, right hand limit, which is 7. Now, let us write the quadratic equation. X square minus sum of roots plus product of roots equals to 0. This is how you form any quadratic equation using two roots. X square minus 10x plus 21 equals to 0 will match with option C, and here you go. Can you see that the option is absolutely right? How many of you were able to do this question with me? Tell me. Yes, are we ready for one more PYQ? Let me know guys. Yes, are you here? Are you guys here? Chalo, one more question I'll be giving you. This is also a KCET PYQ. Half question we'll do it today. Next half, the rest half of the question we'll do it in the next class. Okay? Alright, because we are only focusing on the continuity part. Okay? Alright, so let's do it. So at x equals to 1, the function is continuous or discontinuous. We will only focus on this part because differentiability we are going to do in the next session, correct? So the question we are going to complete in the next session. Okay, so f of x is equals to x cube minus 1, where your x is 1 to infinity, and x minus 1 when your x is minus infinity to 1, correct? Now f of 1, now for continuity we know that how to check continuity. We have to check f of 1 minus equals to f of 1 plus equals to f of 1. F of 1 minus, okay, 1 minus, that means less than 1. So less than 1 means here, less than 1 means here. So basically 1 minus minus 1, okay. So this is going to become 0. Okay, what about f of 1 plus? F of 1 plus is here, greater than 1. So that is 1 plus ka cube minus 1. So this is 0. Okay. What is f of 1? So can you see the equality lies over here? That means square bracket over here. So you have to put x equals to 1 over here. So this is 1 minus 1. So that is also 0. So function is continuous, my dear students, at x equals to 0. It is pretty obvious. So basically C option or D option is wrong. Either A or B is correct. Now we have to check for the differentiability, obviously, to understand whether the function is, which option is correct basically. So this question we will complete in the next video, next lecture. And now we are done with it. Next lecture you have for biology. So do attend at 7:30 biology, Gopika ma'am, right? And if you guys want to connect me over Telegram channel, if you guys having any doubts, so my personal Telegram is t.me/Namrata Jaisinghani. This is my Telegram, so you can add, you can connect there, you can just ping me any doubts. I'll share my PDF there also. And in Karnataka Telegram channel, I hope that you guys are connected. You guys have subscribed the Karnataka channel, and I hope that you all have subscribed to this our brand new channel. Okay, so do that and share this channel, share the video with your fellow KCET aspirants, and I'm gonna see you in the next video. That is going to be on Friday, right? So Friday we'll be doing differentiability, and then once we are done with that, we are going to do a lot of PYQs from KCET as well. This is me, Namrata, signing off. I'll see you all in the next video.